Okay, today we are going to start two's complement. Last week we discussed what is magnitude numbers, magnitude conversions, and sign magnitude, and one's complement we discussed. So today we are going to discuss two's complement. Two's complement. Okay, write down the topic. Two's complement. Two's complement. Two's complement. In short form, you can write 2 apostrophe s complement. That is also possible. Right? Two's complement. Under that, write down. Under that, write down. A single set of bit. A single set of bit is used to form a negative number. To form a negative number. Start with a positive number. Start with a positive number. Complement each bit. Complement each bit. Complement each bit. And add 1 to the LSB. This interpretation includes one more negative value, than positive values. Positive values can be represented. Positive values can be represented as normal binary values. Okay, we'll see how to convert these numbers to 2's complement. I'll take positive 5. Positive 5. Now 5, when you convert it to a binary, 101 is coming, right? 101 is coming, but to represent them with 8 bits, usually we are using 8 bit to represent this uh, one's complement and two's complement. Because of that, I will put another 5 zeros, then all together 8 bits are there. This is positive 5. Positive 5. If I want to convert negative, that is negative 5, represent negative 5, first you find out the positive value 0, 0, 0, 0, 0, 1, 0, 1. Then invert the bits, that is the complement of that value you have to take. That is zeros become 1, ones become 0, like this. Then you have to add 1 to this LSB. Now binary addition we have discussed. So 0, 1 you get 1, here 1, 0, 1, 1, 1, 1, 1. So this is your answer. This is in 2's complement. Now in positive value, normal you in 1's complement and 2's complement, both we are just keeping as a binary value with the 8 bits. But in negative values, if it is 1's complement, you have to just convert it to other side. If it is 2's complement, you have to add 1 to this LSB. That is the difference. then you are getting the answer. Okay, take it down quickly. I will give you some values, you can do them. I'll write here. Minus 10, 12, that is positive 12, minus 15, positive 6, and last one minus 20. Try them out and send me the answers through the chat. I'm going to do that for you all, right? This first one will check your answers. Most of you have good answers. Everyone will check the answers. So first one minus 10. So 10 you have to first find the 10, that is 0, 0, 0, 0, 1, 0, 1, 0. Right? You can take it by dividing the number even, doesn't matter. Then after that you complement the bits, that is 1, 1, 1, 1, 0, 1, 0, 1. Then add 1 to the LSB. There you get 0, 1, 1, 0. Here you get 1, 1, 0, 1, 1, 1, 1. So this is your answer, minus 10. I think everyone has put the correct answers. Yes. Okay, good, right? Then we'll do the second one. That is 12. I'll write it here. 12, it is a positive value. So no need to complement the bits. So you can write 0, 0, 0, 0, 1, 1, 0, 0. That is your answer. Just convert it to binary and keep it 8 bits. So it's a positive value minus 2, positive 12. So you can represent like this. Then next one, minus 15. I will erase this part. Minus 15. So here, first you find out the positive 15, then invert the bit, then add 1. You get, this is your answer. This is your answer. I think, yeah, most of you have put the correct answers. Yes. Then positive 6, I will write here, so no need to invert the bits. 0, 0, 0, 0, 0, 1, 1, 0. So very easy. That is positive 6. Positive 6. Some of you have made the mistakes. Check your answer. You don't want to convert the bits. Some of you have convert the bits even. Check it, those who made the mistake. So without converting, you can just represent them. Positive 6. The last one, minus 20. Minus 20. So first you find out the 20. So 0, 0, 0, 1, 1, 0, 0. Yeah, this is positive 20. Then flip the bit 1, 1, 1, 0, 1, 0, 1, 1. So you are making zeros become ones, ones become 0. Then add 1 to this least significant bit. 1, 1 you get 0. Again you are taking 1 front, then 1, 1 again 0. Here then that one is coming here. Then 1, 0, 1, 1, 1. This is your answer. This is your answer. These all line 2's complement. This whole line 2's complement. Right? Okay. So make sure if it is a positive in 1's complement or 2's complement, if it is positive, you just represent as a binary digit with the 8 bits, right? So don't change them or don't invert them. Invert කරන්න එපා වෙලාවකවත්. ඒක ඔළුවේ තියාගන්න. ඒතකොට වරදින්නේ නැහැ. We are doing this only the positive values. Sorry, negative values. Now I want to tell you another thing. Now if I want to represent 0, if I am Now in ones complement, zeros we had two values, positive 0 and negative 0. But in twos complement, you will be having only one value. And the other thing is, if you get 9th bit, you have to ignore. I will show you. 0, you have to represent with 8 zeros. If it is negative 0, I am going to do that. So negative 0 means if it is ones complement, what you are doing, you are just converting them. This is in negative 0, right? But twos complement, if it is a negative value, what you have to do? Flip the bit, then add 1 to LSB, right? So when you add 1, 1, you get 0, then here 0. You are getting something like this. Now in ones complement, that day we discussed, if it is ones complement, this 9th bit, this is 9 bit, you have to take it here to the LSB and add. It is in ones complement, right? But in twos complement, if you get 9 bit, you have to just ignore that. And you have to write ignore carry bit or most significant bit, right? So you have to write like that. So after ignoring, you will be getting all these are values, zeros. එතකොට මේ 0 එකයි minus 0 එකේ එන value එකයි same. දෙකම එකයි මේ zeros 8ක් නේ දෙකටම because 9 bit we are going to ignore. So in twos complement, you don't have values, separate value for minus 0 and positive 0. That means 0 means only one value is there in two's complement. But one's complement, I think you can remember, you had two values. Values දෙකක් තිබ්බා. If it is 0, minus 0 and positive 0. But two's complement, you will be having only one value for the 0, and make sure if you get 9 bit, you have to ignore that. Okay, write it down in a new paragraph. In two's complement, one value is there for 0. One value for their 0. One value is there for 0. There's no separate value for positive and negative zeros. Positive and negative zeros. Positive and negative zeros. Another rule is if you get 9th bit, when you are representing with 8 bits, if you get 9th bit, when you are representing with 8 bits, you have to ignore that 9th bit. You have to ignore that 9 bit and mention it. So without just ignore, and you have to mention in the exam, you have to mention, ignore the carry bit or MSB, you have to mention it. Take this down as example 0. So 0, I am going to prove that positive and negative both are having the same value, right? That's I have proved here. Take it down quickly. Okay, then we'll see calculations with 2's complement. Write down topic. 2's complement addition and subtraction. 2's complement addition and subtraction. 2's complement addition and subtraction. Write down under that like this. In 2's complement, addition or subtraction, in 2's complement, addition or subtraction, we perform only addition. We perform only addition. So that means even you have to subtract some numbers through the 2's complement, still we are adding. I'll take one example here. I want to find out 5 plus or 5 minus 7. 5 minus 7. So this is subtraction. 5 minus 7. This is subtraction. In 2's complement, we are doing addition. I'll show you how to do that. 5 is positive value. Look at it here very carefully. 5 is positive. You can write the 5 with the 8 bits. 101. So 7 is negative. 7 is negative. So I can write minus 7. First you write the positive 7. Then flip the bits and add 1. So this is minus 7. This is minus 7. This is not the answer. This is not the answer. So I am going to add them together. So I will write it here. Positive 5, my value. Minus 7, negative. Then you know how to add binary values. So put the addition marks. I can remember in 2016 or 17 in paper marking, if you don't put this positive, that is plus marks, your marks will be deducted. It was deducted. It was deducted actually in 2017. I think this kind of question came. So if you don't have this symbol, addition symbol, because in there you have to understand is even you have to subtract, you are adding. That is the theory, right? So when you add them together, 1 becomes 0. Here you get 1, and here also you get 1, 1, 1, 1, 1, 1. This is your final answer. Right? Okay, take it down quickly. I will do another example also. Take it down. I'll take another example. Now this 5 minus 7, I can write like this even. That's why I am asking you to add. Now 5 plus minus 7. Same thing. No? Same thing. Right? So plus minus become minus. So that's why it is saying you have to, even it's subtract, even you have to subtract, you have to add them. That's why it's telling to add them, right? I'll take another example. Uh, 6 plus minus 3. Different ways. This is same as 6 minus 3. Same thing. Same thing here. But I am writing 6 plus minus. So all the time you have to do the addition, right? So 6 positive 0, 0, 0, 0, 0, 1, 1, 0. So that's how you have write 6 with 8. Minus 3, I'll write 3 first. This is 3. Other side 1, 1, 1, 1, 1, 1, 0, 0. And add 1 here 1, 0, 1, 1, 1, 1, 1. So this is minus 3. So I'm going to add them together. So here I am writing 6, 1, 1, 0. Here I am taking the minus 3. 3, 4, 5, 6, 7, 8. I'm going to add them. So put the addition marks. 0, 1 you get 1, 1, 0 you get 1, 1, 1 you get 0. Here 0, 0, 0, 0, 0, 1. So you are getting the 9 bit. So I told you if you get 9 bit, you have to ignore that. You have to ignore. So you are writing ignore carry bit. Must be. Then your answer, I'm going to write the answer here 0, 0, 0, 0, 0, 0, 1, 1. This is your answer in 2's complement. So you can understand if you convert it to binary, you are getting positive 3 because 6 minus 3, you should get positive 3. So you are getting here. But in earlier one, you can't do like that. So I'm teaching it later how to convert decimal to two's complement to decimal. I will teach you that later. That day we discuss how to convert one's complement to decimal. So like that we are discussing that part. So here you can understand 6 minus 3 you wrote. Then add them together. You are getting the 9 bit, that is the carry bit. So ignore that. Then your answer will be this one, right? Okay, take it down also. It's another example. think that is okay. So I'll give you some values. Write down like this. Calculate and represent. Calculate and represent. Following values. Following values in 2's complement. Following values in 2's complement. First one 2 plus minus 10. Next one 8 minus 4. Third one 12 minus 14. Fourth one minus 5 plus 10. Last one 15 minus or plus minus 20. Different way, right? Okay, start them and send your answers through the chat. Then I will check your answers whether they have correct. Take your time and do it correctly. Only minus value you have to convert. Then only add. Remember that. All the time positive values are keeping as a normal binary value. If it is negative only, you have to convert it to binary. That is, you have to complement the bits and add one. Then after that only you can take these numbers and add. Right? Start them. I'll take the first one. 2 plus minus 10. So 2 you can write 1 0. Minus 10. I write it here. 0 0 0 1 0 1 0. Flip the bits. Flip the bits 1 1 1 1 0 1 0 1. Then add 1 here. Then you are getting the 2's complement value. Here 0 1 1 0 1 1 1 1. So I'm going to add that this number I'm taking here 0 0 0 0 0 0 1 0. Then add them together. You get 1 0 1 1 0. There also you get 0 here 1. Then 1 1 1 1. This is your answer. This is your answer. I think everyone has yeah put the correct answer. Most of you, yes, right? This is the first one. This is the first answer. I think you have sent me. Everyone has sent me the answers correct, right? Okay. Then we'll go to the second one. I'm going to erase that. Now, if you can't take it down even, you can, I will upload my video. Then you can go through it again, right? You can go through it again. If you couldn't write something, it's still, you can go through the video and you can post that and you can write if you want. Then 8 minus 4. So 8 I write, this is positive. 1 0 0 0. This is 8. Then minus 4. Positive 4 I am writing. This is positive 4. Then I am flipping the bit, complement. Then add 1 here. 0 0 1. Then I am taking this one here. It's easy for me to write. So when you are writing, you can separately write them. Yeah, your answer will be 0 0. Here you get 1 0 0 0 0 0 1. And here you are getting 9 bit. You have to just ignore must be or carry bit. Then your answer you write it again 0 0 0 0 0 1 0 0. This is your answer. You have to write the final answer later after ignoring. Right? Then I'll go to the third one. Minus 5, sorry, 12 minus 40. 12 I am writing 0, 0, 0, 0, 1, 1, 0, 0. This is 12, positive 12. Then minus 14 I am taking 14 I will write here. This is 14. Minus 14 means other side. Then add 1 here. So I am taking this bit 12. Add them together. So this is your answer. This is your answer. That is for third question. Third question. Yes, you have sent me the correct answers. Good. Then I am going to take the fourth question. Fourth question. Minus 5 plus 10. So minus 5, I'll write it here. First to find out the positive 5. Then flip the bit. Add 1. Then positive 10 I'm writing here. Add them together. You get 0, 0, 1, 0, 0, 0, 0, 0, 1. Here you get 1. No? Yes. Right? 1, 2, 3, 4, 5. Yes. So this is 9 bit. Ignore the carry bit or MSB. So your answer will be 0, 0, 0, 0, 0, 1, 0, 1. And I think you have done it properly. Yes. Okay, then we take the last one. Fifth one. I'm going to do it here. 15 plus minus 20. 15 plus minus 20. 15 I'm writing positive value. 0, 0, 0, 0, 1, 1, 1, 1. This is 15. Negative 20 I'm going to write 0, 0, 0, 1, 0, 1, 0, 0. I'm going to flip the bits. 1, 1, 1, 0, 1, 0, 1, 1. Then add 1. 0, you get 0, here you get 1, 1, 0, 1, 1, 1. So I'm taking this value here, 0, 0, 0, 0, 1, 1, 1, 1, add them together, 1, 1, 0, 1, 1, 1, 1, 1. This is your answer. This is your answer. So that is 15 plus minus 20. I think, yeah. Most of you have put the correct answers. I think you can understand that. Then we'll go to another type of thing that is when you are getting 2's complement value, how to convert it to decimal value. Write down the topic. Convert. Write down the topic. Convert 2's complement values to decimal value. Convert 2's complement values to decimal value. Okay, I'm going to do two examples, then you can understand. Now I am getting something like this 0, 0, 0, 0, 1, 0, 1, 0 in 2's complement, right? 2's complement. So if you get a question like this, You have to check this first bit. First bit you have to check. If it is 0, you decide it is a positive value. If it is 0, you decide it a positive value. So you can just convert it to binary, sorry, decimal 1010, that is 2 to the power 0, this 1, 2, 4, 8, like that you can take. And take that value, 2 is there, plus 8 is there, positive 10, positive 10. So I am writing another value here, 1, 1, 1, 1, 0, 0, 0, 0 in 2's complement. In 2's complement, they have to give whether it's a 2's complement or 1's complement, right? So if it is 2's complement, then again you are checking this MSB or the most significant bit. Now earlier it was 0, but here it is 1. So if you get a 1, that means you decide it as a negative value. First you decide, okay, this is a negative value. Then you are going to flip the bit. I'm going to flip 0, 0, 0, 0, 1, 1, 1, 1. Then add 1 to this LSB, that is last value. So here you get 1, 0, again 0, 0, 0, 1, 0, 0, 0. Right? Then you convert it to decimal. Now only you are going to convert it to decimals. That means 1, 2, 4, 8, 16. So you are getting the value 16. But remember, here we decide it is a negative value. You have to put the minus value. You have to put the minus value. So minus 16 is the correct answer. I think you can understand. Write down like this first. Before you take down the example, write down like this. To convert 2's complement number to convert 2's complement numbers to decimal value. First check the most significant bit. First check the most significant bit. Most significant bit. If it is 1, 0, if it is 0, so it is a positive value. If it is 0, it's a positive value. Just convert it to binary to decimal method. Just convert it to using binary to decimal method. If the most significant bit is 1, that is the first bit. If the first bit or most significant bit is 1, it is a negative value. It is a negative value. Flip the bits. And add 1 to the least significant bit. And add 1 to the least significant bit. Convert that binary value to decimal value, convert that binary value to decimal value, convert that binary value to decimal value and keep it as a negative decimal value. And keep it as a negative decimal value. Keep it as a negative decimal value. Okay. Take down these two examples. This is a positive valued example. This is how you deal with a negative 2's complement value. Okay, take it down quickly. Okay, I will give you some calculations. Write down like a question. Convert following 2's complement values to 2's complement values to relevant decimal numbers. Relevant decimal numbers. Okay, take them down. Last one, I will. Last one. Okay, try to do that and send me the answers. First one, it is a positive value. So because it's starting with 0, just convert it to by decimal 1, 2, 4, 8, 16, 16 plus 4 plus 1. So your answer will be 21 for this one. So everyone has put the correct answer. Next one, this thing you have to convert the bits 0, 0, 1, 1, 0, 0, 1, 1, add 1 here, 0, 0, 1, 0, 1, 1, 0, 0. 52. So there you get minus 52. Second one will be the minus 52. Right? I'll just tell the answers. Third one, it should be minus, this is 52 minus, this is minus 19, minus 19. This is you get positive, that is 34. Last one you are getting minus 47. I think you have sent the correct answers. Yes. Yeah, right? So that's good. Then we'll go to small theory part, and there are some more calculation, more representations are there. Just write down in a new paragraph.
Sir, can you repeat the second one?
Second one, how we did that?
Yes.
52, yeah? Yes. So here you get 1, 1, 0, 0, 1, 1, 0, 0, right? Then you have to flip the bit. 0, 0, 1, 1, 0, 0, 1, 1, right? Then add 1 here. 1, 1 becomes 0. That one is coming here. Then that one with 0. Again, 1 is coming here when you're adding that, right? And here 0, 1, 1, 0, 0. So that answer you have to convert it to decimal. Decimal, how to convert? 1, 2, 4, 8, 16, 32. Like that you have to put. That is, when you are converting binary to decimal, you have to put the 2 to the power, starting from 2 to the power 0, you have to put the values. If you have 1s here, 32 is there, 16 is there, 8 is not there because here 0, so 4 is there. Others are 0, so other values you are not taking. So 32 plus 16, 48, 48 plus 4, 52. But 52, because of this one is there, we have decided first it's a negative. So because of that, you put minus 52. Is that clear? Ekarida, is that clear?
Yes, sir.
Okay. Right. So that's how we can do that, right? Okay. Write down a new paragraph. New paragraph. Sign magnitudes, that is what we discussed at the beginning. Sign magnitudes can be used used when there's no when there is no add or subtraction of data. When there's no add and subtraction of data. They are used in they are used in they are used in analog and they are used in analog and analog to digital conversions. They are used in analog to digital conversions. They are used in analog to digital conversions, and they have limited use and they have limited use and they have limited use as they require complicated arithmetic circuits as they require complicated arithmetic circuits. In new paragraph, write down new paragraph. Once complement are used, once complement are used, once complements are used, because simpler design in hardware due to simpler concept new paragraph. Two's complement makes it possible to makes it possible to build low cost high speed high speed high speed high speed hardware hardware to perform arithmetic operations to perform arithmetic operations. Okay, next one, topic write down. Fixed point. Fixed point numbers. Fixed point numbers. Fixed point numbers. So in fixed point means your this decimal point will be the same place. Decimal point will be the same place. Now you have in your right hand side you have four values. This one also you have four values. Your answer when you are adding them together 842.933. Your answer also having the same decimal values here, same, the point is at the same place. Point is at the same place. That's why it's called fixed point. Fixed point, write down there under fixed point numbers. Under that write down. In calculations, involving fixed point, in calculations involving fixed point numbers, involving fixed point numbers, that have a fixed number of digits after the decimal point. Fixed number of digits after the decimal point. The decimal point is located in the same position in each number, same position in each number. Okay, take this down quickly. So decimal point, each number you have the same place. Then write down next topic, floating point numbers. Floating point numbers. This is a bit confusing part, so concentrate this one, floating point numbers. First we'll write down the description. Under that write down, floating point numbers are used to floating point numbers are used to represent numbers with fraction numbers with fraction very small numbers very small numbers and very large numbers and very large numbers. Numbers can represent numbers can be represented numbers can be represented single precision 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 single precision floating point within bracket put 32 bits or double precision within bracket put 64 bits double precision within bracket put 64 bits floating point but here we are discussing only single precision because you are in your syllabus you have single precision only. So but here we are discussing only single precision floating point. Single precision floating point. The steps you have to follow are given below. Okay, right? This is bit confusing part. නිසා හොඳට බලා ගන්න. අපිට මුලින්ම හම්බ වෙනවා we are getting the number to represent floating point. Single precision 32 bit තමයි in your syllabus you have to discuss. 8 bit 16 or 32 64 ඔය ගොඩක් තියෙනවා but I'm discussing only 32 bit කියන එක විතරයි because it is they are all your syllabus, right? Actually English medium syllabus. English medium syllabus you can't find that one even, right? Okay. I'm getting a number first. I'm taking the positive value 12.25 to single precision floating point 12.25. First step is you have to convert it to binary. Convert it to binary. So you now you know how to convert this type of a thing into binary. So 12 you can just divide by 2, you get something like this. Let me 1100 for the 12. 0.25 we have discussed how to convert them to binary. You have to multiply by 2, you get 0 5, again multiply by 2, right? So this is your answer. This part is your answer. So you can write, I will write the answer 1100.01 to 2. This is your answer, right? So when you convert it to binary, okay, write down first step. Convert decimal value to binary. Decimal value to binary. Okay, take this down. Take this answer. Take it down. After taking it down, just send me a message. Then I know you have take it down. Then I can start the other part. Okay, I think you have taken them down. So this is first step is convert them to binary. Then second one write down, put it in standard form. Put it in standard form. Put it in standard form. So I am going to erase this part only. I am keeping that value only. Now my binary value is here. I am going to put it to standard form. Standard form means you are taking this decimal place to here one after the one value. That is, I can write 1.10001. Right? To get the original one, you have to multiply it by how many points it is going to right hand side to get my original one. Now I am here. So 1, 2, 3. 3 times I have to go, then only I am getting the original one. This value I can take by passing this decimal value right side 3 times. So I can write 2 to the power 3. 2 to the power 3. So that's how you put it to standard form. Now you have a value, then you take the value, decimal value, bring it front before the one value. Then you can write it how many values you have to go to right hand side to get the original one. So in my case here in this example 3. So this is called standard form. Okay, take it down. Second step I think you wrote. Put it to standard form. So take it down. Okay, third step write down. Third step write down. Bias, B-I-A-S, bias. The exponent, bias, the exponent by using excess K method. By using excess K method. Excess K method. Excess K method. That means this is a method you have to memorize this 2 to the power K minus 1 minus 1. Where this K is number of bits for exponent. Exponent, there are 3 parts: exponent, mantissa, and sign bit. Don't worry about that. K is number of bits for exponent in your 32-bit representation all the time. All the time, K is 8. Single precision, floating point system, all the time K is 8. So if you put that value here, you can write this down like this: 2 to the power 8 minus 1 minus 1. So 2 to the power 8 is 128. 128 minus 1, 100. 2 to the power 8 minus 1 means 2 to the power 7. To the 8 minus 1 to the power 7. 2 to the power 7 is 128. 128 minus 1, you get 127. So all the time, K method, when you apply the K method, this is 127. 127. That value you have to add. Bias means you have to add this part to this one. I'll write it here. 127 plus 3. 3 is getting from this one. 3 is getting from this one. Right? Take it down. K4 exponent, take it down, then I'll write, this is in the third step, I think, yeah. Bias the exponent by using the XSK method. There write down like this. After that only you write down this part. K4 exponent, K4 exponent, this K4 exponent, K4 exponent, and it is 8, and it is 8, and it is 8. All the time, all the time, all the time. In single precision, floating point system, floating point system. Bias that value to get the exponent, bias that value to get the exponent. Okay, take it down. First you take this down, then this part is adding. Your answer will be 130 is the exponent. 130 is coming for the exponent. Take them down quickly. Okay, then fourth step, write down. Represent the value. 1 bit for sine, 1 bit for sine, 8 bit for exponent, 8 bit for exponent, 8 bit for exponent, and 23 bits for Mantissa. 23 bits for Mantissa. Okay, look at here. Now I am writing like this. This bit I am using sine bit. This is for 0. I'm using another, I'll take one bit. I'll put like this one. Here, this is for exponent. There you get 8 bits. 8 bits. Here you get mantissa. Mantissa. That is 23 bits. So altogether 32 bits. Okay, look at here. How we are going to represent this our number with the 12.225 with the single precision floating point. Here sign bit. When you put a sign bit, you have to check whether it's a positive or negative. Positive, you put 0. Negative, you put 1. So in my question, I gave 12.25. So 12 is positive. So you put 0. You put 0. Then exponent. Exponent, we have created 123, 130 here. When you convert it to binary, you get something like this. 1, 2, 3, 4, 5, 6, 7, 8, 2, 7. Yes. This is the exponent when you convert this decimal value to binary. So I'm going to write it here. 1, 0, 0, 0, 0, 0, 1, 0. Then mantissa. Mantissa is this value. I have to take it from here. So after making it to a standard form, you are getting some value right side the decimal point. දශම ස්ථානයෙන් දකුණු පැත්තේ තියෙන value එක අපි ගන්න. එහෙනම් මේක මම ලියනවා 1 0 0 0 1. So here 1 2 3 4 5. 5 bits are there. Bits පහයිනේ තියෙන්නේ. But we have to represent 23 bits. පහයි තියෙන්නේ. එහෙනම් තව 18 bits I have to put. එහෙනම් මම මෙතන 18 zeros දානවා. 3යි 4යි 5යි 6යි 7යි 18ක් දාන්න. right? එතකොට ඔයගොල්ලත් එහෙම දාගන්න. මෙතන you get 5 bits from this part to make it 23 bits. So this is called single precision with the 32 bit where you get 12.25 can be represented with single precision floating point. So this is your answer, right? So there write down next point. Now you wrote that description. Take this down. Take this down. right? So I will repeat the step. This is a bit confusing. That's why that's why I told you. When you get a decimal number, convert it to binary and make it to standard floating point number. ඒක තමයි අපි මුලින්ම කරන්නේ. මෙන්න එහෙනම් standard form එකට දාගත්තා. decimal place එක කී පාරක්ද මේ පැත්තට පයින්නේ කියලා you have to put it here the value. power එකක් විදිහට දෙන්න. ඊළඟට හැම වෙලේම access k method කියන්නේ දැන් අපි කතා කරන්නේ single precision විතරයි. ඒ නිසා ඒක මතක තියාගන්න හැම වෙලේම 127 එන්නේ. මේ 127 එකට ඔයගොල්ලන්ගේ මේ මෙතන නම්බර එකෙන් ආපු power එක ස්ටෑන්ඩඩ් ෆෝම් එකෙන් ආපු power එක මේක මයිනස් වෙන්නත් පුළුවන් ඈ මම මේක එක්සැම්පල් එකක් ඔයගොල්ලන්ට පෙන්නන්න මේක මයිනස් වෙන්නත් පුළුවන් මේ වැලියු එක මෙතනට ඇඩ් කරන්න ඇඩ් කරාම ඔයගොල්ලන්ට එනවනේ වැලියු එකක් ඒක 8 bit වැලියු එකක් තමයි ඩෙෆිනිට්ලි එන්නේ 256 වලට වඩා අඩු වැලියු එකක් අනිවාර්යයෙන් 255 වලට වඩා ඒතර මේකට කන්වර්ට් කරන්න බයි මේක කන්වර්ට් කරන්න බයි ඊට පස්සේ ඔයගොල්ලන්ගේ සිංගල් ප්‍රෙසිෂන් format එකට යන්න පළවෙනි bit එකෙන් කියන්නේ sign bit එක if it is positive නම් මෙතන 0 දැම්මා negative නම් 1 දැම්මා exponent එක ඔයගොල්ලන් මෙතනින් එන value එක binary කරලා ගන්න value එක put it here mantissa එක එන්නේ හැම වෙලේම මෙන්න මේ අපේ standard form එකේ decimal place එකෙන් එහා පැත්තේ තියෙන value එක දැම්මා ඉතුරු ටිකට zeros දාලා ඉතුරු ටිකට zeros දාලා 23 bit වල ගන්න. එතකොට 32 bit වලින් තමයි අපි මේක represent කරලා තියෙන්නේ. right? ඒකේ මම example කිහිපයක් ඊළඟ දවසේ කතා කරන්න බලාපොරොත්තු වෙනවා. එතන ඔතනම් පල්ලෙහෙන් මෙහෙම ලියා ගන්නකො. මෙහෙම ලියා ගන්න ඔතනින් පල්ලෙහෙන්. In this format, if you are using more bits for Mantissa, it give more accuracy. And more bits for exponent. It increase the range. Within bracket put if you are using double precision 64 bit අපි use කරොත් කරන්න යන්න එපා මම නිකන් කියන්නේ if you are using double precision 1 bit for sine 11 bit for exponent and 52 bits for 2 bits for Mantissa 52 bits for Mantissa right so that's how you have to represent so next week we are going to do some more calculations that make product confused way just go through the video I will upload the video also මේ part එක නැත්තම් confused වෙනවා so I will do some more calculations on next week by next week we can finish this lesson lesson එක අපි next week එකේ ඉවර කරනවා then after that we are going to start logic gate so if you have friends ask them to connect and check whether this class is suit for them ලා බලන්න ඔයගොල්ලන්ගේ යාළුවෝ ඉන්නවා නම් මට message එකක් දාන්න කියන්න right so next week go through all these notes related to unit 3 so we are going to discuss past paper questions also We are going to discuss after finishing this lesson. We are going to discuss. That's how we are doing. Hammer unit came up. We are doing some past paper question. Then you can understand whether you can answer for them. නේද? ඔයගොල්ලන්ට answer ගන්න පුළුවන්ද බැයිද කියන එක ඔයගොල්ලෝ check කරගන්න පුළුවන්. එතකොට ඔයගොල්ලෝ කොච්චරක් වැඩ කරලා තියෙනවද, how much you have work කියලා හොයාගන්න පුළුවන්. ඒක නිසා අපි next week එකේ ඒ ටික කතා කරමු. Okay, we'll finish for the day. Have a nice day. Thank you.